Large language models are currently passing the bar exam, drafting complex software, and writing essays that are indistinguishable from human work. We are seeing what looks like science fiction come to life. These systems communicate so fluently that it is easy to imagine a conscious mind behind the screen, processing ideas with the same nuance as a person. Yet this same artificial intelligence, which can write a master's thesis, often fails a simple visual logic puzzle designed for a 5-year-old. This failure exposes the reality behind the curtain. The system possesses no internal concept of the world, no understanding of physics, and no actual brain. That blinking cursor is simply playing the world's largest, fastest game of fill-in-the-blank, moving forward without ever forming a true thought. The machine builds its responses by ingesting billions of pages of text from across the internet, cataloging how humans have linked words together over decades. Given a prompt like, "The best thing about AI is," it calculates probabilities for the next word. Learn has a 40% chance. Once selected, it instantly recalculates the list for the next space. This process continues one word at a time, moving blindly forward until the entire essay is complete. If the process is purely mathematical, why does the machine generate a different answer every time you ask the same question? Always picking the most probable word makes text flat and repetitive. To avoid this loop, developers use a temperature parameter, introducing controlled randomness. Higher temperature forces the AI to skip the top choice, creating unexpected variations. What we perceive as a creative spark is in reality a mathematically weighted dice roll designed to keep the text from stagnating. For a machine that only processes numbers, identifying which words logically belong together requires a different kind of map. The algorithm translates every word into mathematical coordinates on a giant spatial map. Because cat and dog appear in similar sentences, they drift into a tight cluster. Unrelated words like turnip rocket to the extreme opposite edge. By mapping billions of these relationships, the system modeled human grammar entirely through geometry, without ever being taught a single rule of English. The system navigates these coordinates in a massive space of meaning, finding its way through the data without understanding the words it uses. Generating an essay involves tracing an efficient path between these coordinates, following the trajectories established by the humans who wrote the original training data. The machine acts as a sophisticated mirror, reflecting the patterns of our collective digital history back at us. This revelation shifts the focus from the software to ourselves. The real surprise is not the raw power of the code, but what it suggests about the nature of our own communication. If a statistical engine can replicate our speech so effectively, it indicates that human language follows more consistent, law-like patterns than we once believed. The system works because our thoughts and expressions follow a degree of order that is more regular and more predictable than we assumed.